If there are no further questions or comments, then I'll just like to ask Mr. Rohit Prasad from Enapter in Germany, are you on right now? And first, thank you very much, Vinit. It's very good having you here. Yes?
Yes, good morning. I'm here. I'm ready.
You are ready. Very good.
Absolutely.
Welcome. And we look forward to hear your presentation, which is called Hydrogen Energy Storage.
Thank you so much. I'm sharing my screen now. I hope you're able to see my presentation in full screen mode. Yes, perfect. Well, thank you so much for the introduction. I've actually attended previous conferences organized by yourself. The last time we were at this Small and Wind conference, we found it really interesting. We're very happy to make a presentation today. Essentially, Enapter develops hydrogen electrolyzers. Of course, you might have heard of this technology. The idea is to produce hydrogen from excess renewable energies. It can be either solar or wind. And what I will try to show today is all the possibilities that you have of using hydrogen. Now, industries gives them access to many different end applications. So what you're seeing on this graph is a very simple representation of something that we like to call the missing link. So the electrolyzer is a missing link to connect traditional technologies of renewable energy producing electricity to be able to enter into markets that have been using hydrogen until now. So hydrogen is nothing new by any length of the imagination. Hydrogen has been used in many industrial applications for decades now. Even electrolyzers themselves, in fact, have been around since the early 1920s and 30s. They're only starting to catch on now as the prices come down, of course. So hydrogen can be used in fuel cells, of course, a major and fast growing sector for decarbonization of mobility, as an example, or stationary power. The production of synthetic fuels such as ammonia or methanol has been using hydrogen for a very, very long time as well. Again, what I'm trying to stress, and with the next slides, you'll see some of the use cases that we have, some of the projects we've done. The idea is quite simple. The renewable energy sector is growing very quickly. There is also an existing sector that uses hydrogen in mass quantities. The electrolyzer here is the missing link that can allow both these industries, in a sense, to achieve sector coupling. I'll jump right into our use cases, and after that, tell you a little bit about our products as well. So it's important to understand that hydrogen is not just a way to store electrical energy. It's not just protons. Hydrogen is a molecule, and this distinction needs to be understood in order to grasp all the, let's say, the possibilities of hydrogen. Hydrogen is the molecule of the future, not just the energy carrier of the future. About 30% of all the energy consumption is electrons, so it's electricity. Sometimes what's somewhat skipped over is the fact that 70% of energy consumption actually goes into industry, transport, and the heating sector, which are molecules and not exactly electrons. Now, hydrogen has the capacity, the possibility to bring both of these sectors together. It can be used, as I said, for producing fuels. It can be used for heating. It can be used directly to provide power. Of course, you can re-electrify hydrogen, so to speak, via fuel cells, as an example. And it can be used directly in industrial processes. Just to name a few, glass production is a process that has viability to use hydrogen in its furnaces. Already mentioned ammonia, a massive, massive industry that has been using hundreds and hundreds of tons of hydrogen on a monthly basis across the world. So the possibilities are simply endless for hydrogen. It's only a matter of, let's say again, connecting the renewable energy sector to these industries that use molecules of hydrogen. So Enapter has been around for a few years now. We've already had projects in over 30 different countries. We're growing very quickly. I'll dive into some of our use cases just to give you an idea of what is possible with hydrogen. So residential energy storage is it's very traditional sort of use of, if I may say traditional, for electrolyzers. The idea here is quite simple. This particular project takes solar energy into account, but of course that can be simply replaced with wind energy production as well. The idea is quite simple. The sun doesn't shine every day, the wind doesn't blow every day. You have times during the year, during the months, that you have a lot of excess wind or solar energy. And it's, well, you have to find a way to store this energy instead of losing it in some manner so that it can be used at a later stage. Now, this project is an example of how excess solar energy is converted into hydrogen, stored on site, and then reconverted back to electrical heat energy via fuel cell technologies at a moment when that when the sun doesn't shine, for example, or the wind doesn't blow. So power on demand. This kind of solution can allow small communities, we'll get to that in a second as well, but small communities, small houses to go completely grid independent and rely entirely on renewable energy sources, which is to some extent possible with batteries as well, but it certainly doesn't cover the energy demand of a user for an entire year if you're simply using a battery solution. So the combination here is, again, solar or wind with batteries as well, with hydrogen storage, hydrogen electrolyzers, and fuel cells to give complete independence. Here you see an example of our electrolyzers. I'll get into the products a little bit later again, but you see that our products are very simple, standard, modular solutions, 19-inch rack mountable, very easy to integrate, very easy to install at whatever location you might have. Power to heat, of course, is another very interesting application. So hydrogen can't simply be burned in furnaces to produce heat. It can be burned in traditional combustion engines as well to produce heat. The idea here is, again, to link a source of energy, in this case solar, but of course also wind is possible, to heat production, which perhaps doesn't make sense on first glance, but with hydrogen and electrolyzers as a missing link, you can connect these two consumption and load profiles with one another. Again, you see an example of how our electrolyzers, modular solutions, can be installed in racks, indoors or inside containers. Very simple, easy integration of 19-inch mountable rack modules. Refueling, of course. So certainly many of you have heard of hydrogen over the last months and years, and there are policies being put into place all across Europe to decarbonize the energy sector, but also decarbonize the mobility sector. And hydrogen gets a lot of, let's say, attention for these. The idea is quite simple: producing hydrogen from green energy sources that can power, in this case, a drone, but quite easily also power vehicles. The connection between renewables and a fuel cell vehicle can be made quite easily over electrolyzers and a refueling station. Industrial applications, again, these have been around for a very, very long time. Hydrogen is not new by any stretch of the imagination here. Ammonia production is one of the major off-takers of hydrogen all across the world. The idea, I keep repeating this, but I do want to stress that there's the possibility to connect renewable energy sources with industrial applications like this that has perhaps not existed until now. Power to gas, of course, there's production of ammonia, as I already mentioned, as well as methanol that can be used in different applications. There are also ideas and plans being put into place to, in fact, feed hydrogen directly into the grid. In certain countries, Germany for sure is taking a lead on some of these activities. And it will be a very interesting area to see how that progresses in the coming years. Coming back to microgrids, it's very similar to the first application we looked at, residential energy storage. The idea is quite simple again. You can have small communities that traditionally have been probably using diesel generators. I mean, these can be areas that are hard to reach. There's no possibility, or it's very difficult, let's say, to install a complete new grid or to upgrade a grid in certain areas like this. I'm sure many of you yourself are familiar with such communities. You can, with the installation of hydrogen technologies here, you can go completely off-grid. You can rely entirely on renewable energy sources, maybe be it wind or thermal or solar or whatever it may be. Again, it's a simple, very simple sort of solution. It's a combination between a primary energy source, wind, solar, with hydrogen electrolyzers, hydrogen storage on site, and also fuel cells or any manner of technology that can let's say, reconvert hydrogen back to electricity and even heat. Another example of mini grids, this is a project we have done in Thailand. This one relies entirely on solar, and of course, many applications of that nature. I'll skip into now the products that Enapter creates. So our mentality at Enapter is very different from what you might be familiar with if you've researched electrolyzers already. Our mentality is to stay modular and scalable. We believe in creating products and not projects, at least on our end. We have one flagship technology, one flagship product, and that's the EL 2.1 electrolyzer, which you can see pictured here to your left. It's 19-inch, mountable into a simple standard rack, can be installed indoors or outdoors, as you like. The price for one of these units is about 9,000 euros, which is probably unheard of on the market. But we're able to achieve these scales, this modularity and this price, relying on the kind of electrolyzer technology that we have patented. Again, if you've heard of hydrogen electrolyzers, you've probably heard of alkaline technology or PEM technology, PEM. What we develop is somewhere in between, but better, I'd say, than most. It's the AEM electrolyzer technology. It's anion exchange membranes. The difference between AEM, alkaline, and PEM is, to come to a very simple level, it's easier, it's less complicated, and it requires less cost-heavy materials to produce. This is part of the reason why we've been able to address the scale of electrolyzer at such a low cost, whereas most of our competition, most of the other suppliers in the market are always aiming to go bigger and bigger with their electrolyzer technologies. Our goal is to go small and modular and scalable. We believe really that the only way to bring down the cost of hydrogen in the future is to go into mass production, and it's a lot easier to mass produce something that's scalable, that's standard and doesn't change, let's say, from project to project. This represents a mentality that's, again, nothing new in the industry. If you take a look at the IT sector back in the 1970s and 80s, there was a shift from centralized large-scale supercomputers, if you could call them that, down to personal computers. We are bringing the same mentality back to the hydrogen sector. Again, this might be something new in the hydrogen electrolyzer business, but this kind of modularity and the idea of mass production is not new at all, neither in the solar industry nor in the IT industry. To give you a very quick example, if you look at a solar power plant that's producing however many gigawatts of power, it's made up of much, much smaller, let's say 300 or 400, 500 watt solar panels. Again, they've been able to bring down their costs over the last 20 years drastically by approaching their industry the same way that we are approaching now the hydrogen industry. Again, modularity, scalability, and mass production of a standard building block. I'll skip this. I think I've already said a few words about this. So again, this is our flagship product. It's the EL 2.1. It produces just over 1 kilogram of hydrogen in a matter of 24 hours and requires a power supply of 2.4 kilowatts. Completely scalable, of course. I'll come back to those in a second. Completely scalable, of course. You can have multiple modules installed either indoors or outdoors in the formation that you see here, simply in racks to reach any kind of production capacity you might be looking for. There's, generally speaking, two ways to dimension an electrolyzer. You could say, one way to do it is simply to say, and to understand how much excess renewable or wind energy you have over the year, simply provide that power to an electrolyzer and find an off-taker for the hydrogen. You could also work backwards by saying, I have an off-taker for hydrogen who requires a certain amount on a daily basis, a monthly or yearly basis, and we dimension the electrolyzer size based on those requirements. Of course, then the appropriate amount of power will have to be provided to the electrolyzers. I'll go back a couple slides and draw a distinction again between our AEM technology versus the PEM technology. It's important to understand there's a lot of discussion always about what is the efficiency of the hydrogen production, how much power is really required. So we'll speak for ourselves. When we say 2.4 kilowatts of power required to produce 1 kilogram of hydrogen in a matter of 24 hours, this hydrogen comes with a pressure of 35 bars and 99.9% purity. That's our standard. It's important to understand this because high pressure stacks, high pressure production of hydrogen is certainly an advantage on the storage, and it's definitely a good, let's say, an indicator that the same amount of power can produce hydrogen at 35 bars. We have a very, we've done comparisons to, let's say, other providers of electrolyzer technology on the market, and we're landing, if not better than all, certainly better than most, with an efficiency of over 60%. Again, part of the reason why we've been able to modularize the technology at this scale is because the AEM electrochemistry allows us to use simpler construction, cheaper construction of the stacks and the electrolyzer modules themselves, allowing us, again, a capex of about 9,000 euros for one electrolyzer module. I mentioned the scalability. Of course, depending on your project, you might have, let's say, 100, 200, 300 kilowatts of power available as well. We have solutions for this, standard containerized solutions. Again, relying on our modularity, not developing new technologies or new electrolyzers for each project, but relying on our scalable electrolyzer technology to reach any scale that's possible. So a solution like this might be useful for, let's say, an excess power generation of somewhere around 200, 300, maybe 400 kilowatts. Going further, we have under development currently also utility scale electrolyzers that are touching the megawatt range and going even beyond that. Now, we also believe not just in producing good hardware, but producing the best software that goes with it. So Enapter has its own proprietary energy management system. Some of the benefits of this are the connection of our electrolyzers with your monitoring system, if you have one, or simply using our monitoring system, not just to control the electrolyzer, but also via our extensions, what we like to call universal communication modules. Via these, you are also able to integrate third-party equipment. It could be solar panels, it could be the control and monitoring of your own wind installations, together with hydrogen storage or fuel cells. Whatever your complete solution may look like in the end, our energy management system allows you to monitor the complete installation quite simply over your mobile app, our mobile app over your phone, or also via the Enapter cloud online. Our goal is to bring down the capex cost of hydrogen down to €1.50 per kilogram. We believe this is a very ambitious and it's a goal that has to be reached if we want to have the mass, let's say, adoption of hydrogen across the globe in all the major industries. And we're actively pursuing this target. If some of you have already heard of Enapter, you may have heard our plans to go into mass manufacturing in the next years. In fact, we are going to automate the manufacturing of our electrolyzers. Again, coming back to the principle simply of this happen in the next 2 and 3 years. And that's how we intend to reach our goals. So just to summarize, Enapter has a proprietary, a patented AEM electrolyzer technology that is very different from something you might have seen on the market. Our mentality is to link renewable energy industries to existing industries where hydrogen has already been used. We're very active, we're very ambitious, and we do believe that we can change the world. I will stop with that, and I would be very, very happy to take any questions that anybody has for us.
Thank you very much, Rohit. Very interesting, and I think that this storage problematic, you can say, is very interesting, because wherever you are having wind turbines, you are producing electricity which can be transformed to hydrogen, and you can be stored that way around. We do have a question from Mohammed. Please, Mohammed.
Yes. Well, that was an outstanding product that you have. I would like to ask about the comparison between the batteries and also your Enapter for 10 kilowatt hour, for example. what is the prices? Could you have a brief comparison between them?
I think it's important to take this question into a little bit of context. So if we'll take the example again of our microgrids or residential energy storage. Let's say you're relying on solar, and I keep saying solar, of course it's transferable to wind. Let's just say my own personal experience is more with solar, so I'll stick to that for now. But you have a lot of solar energy in the summer, especially in countries like Europe, Central Europe, Northern Europe. You have a lot of solar production in the summer and almost little to none in the winter. So you have a source of power in the summer, excess in fact, that somehow needs to be transferred to the demand points in the winter. It's not in most cases, yeah, I would like to say all, but of course I can't say all, but in most cases, it's not possible actually to do this just with a battery solution. Technically it's feasible, of course, but the amount of batteries you would need of this excess solar energy into the winter months starts to get somewhat excessive or ridiculous to some point. To give you an example, there's a project in Switzerland where you have about 100 kilowatts of peak solar being produced. All of that energy is stored as hydrogen at the moment and transferred into the, let's say, carried over into the winter months and used then over a fuel cell. If we were to remove the hydrogen and fuel cell aspect of this solution, you would have to compensate that by adding roughly 100 Tesla batteries. So to come back to your direct question, to compare 10 kilowatt hours of batteries versus hydrogen, it should always be taken in the right context, because there are certainly applications where battery cannot get the job done. And then it's not so much a matter of the price, but you only have very few technical options, let's say, and hydrogen is the best of those.
Well, let me change my question. What about the energy storage of a 1 kilogram hydrogen? As you said, you are going to decrease the price of the hydrogen storage for 1.5 euros per kilogram. What is the energy storage of this amount of hydrogen?
So 1 kilogram of hydrogen inherently contains 33.3 kilowatt hours of energy. Then it becomes a question of how you reuse the hydrogen. To give you an example of a fuel cell, fuel cells have roughly 50 to 60% electrical efficiency. What that means is when you convert this 1 kilogram back into electricity, you will get about 20 kilowatt hours of electrical power, and the rest can be used for heating. So the energy, of course, is never lost. If there's a need for thermal, there's also a possibility of using it.
Well,
thank you very much. Oh, sorry.
Sorry, that's great. Thank you very much.
No, well, if you have more, because we have other questions as well coming in. But we'll just take that and then you can come back. Mike Berger, you have a question?
Yes, Rohit. I'm wondering if you can comment on the ability of the electrolyzer to take a highly variable input, for example, a direct connection to a wind turbine, or does that 2.4 kilowatts need to be quite steady?
So steady is always good, of course. We are in fact doing research and some tests into connecting our electrolyzer stacks very directly to renewable energy sources. Now, the electrolyzer itself has a reaction time, and as long as the power demand stays between that reaction time, it shouldn't be an issue. However, adding some kind of short buffer between the electrolyzer, it could be the grid itself that acts as a buffer or a small battery. It's never a bad idea, let's just say, but depends again on the variations you expect from your power source. And if they match with the electrolyzer, should be fine.
And then a quick follow-up question. A U.S. company, Plug Power, that is a fuel cell company building fuel cells primarily for forklift applications and that sort of thing to replace batteries, have just raised a little over $1 billion US to create what they call hydrogen production gigafactories, drawing on the Tesla terminology. And I just wondered whether you were aware of what their plans in terms of electrolyzers. Is that something that you can comment on, the scale, something at a huge scale that they're talking about?
I can't comment too much on that, except perhaps say the fact that come to us and we'll make you a better offer.
Very good. Thank you.
Thank you. Muhammad, you had a further question, as I remember.
No, I was just thanking the Rohit.
Yes.
Well, I don't have any question for the
Okay.
question.
Yeah. Are there any comments to what has been up here?
Well, if I may make a comment, you know, this conference was very interesting for us. Traditionally, of course, wind has been thought of as, you know, megawatt scale wind turbines and very, very large scale. So this is very interesting, this kind of conference for us, because the power ranges that are being discussed here, small and medium, fit very well into the product line that we are developing ourselves. I think there's a lot of synergies here. I would personally love to hear back from any and hopefully all of you in the coming days and weeks. If there are any questions, of course, I think my contact details are being shared.
Thank you. Thank you for your kind words. So yes, we do hope that everybody will have something out of these webinars or sessions or conferences or what we can call it in these Corona times. But we will have, after the next presentation, we will have a break.